we will see how to construct the decision tree with some Boolean functions so that it will be easy for you to understand the actual essence behind the decision tree. Now let us see. Give the decision tree to represent the following Boolean functions. So 4 Boolean functions are given. You have to write the decision tree for all the 4 functions. So for every function, we are going to write one decision. Now let us consider the first function. Your first function is A and not B. So what is the meaning of this function is, it is a Boolean function. That means that it will accept the input, which is going to have either true value or otherwise false. Because your input should be Boolean value. It can have either value as true or otherwise false. And this function is going to return you an answer. And that answer will also be either true or false. Okay, input is Boolean, output is also Boolean. So now, every Boolean attribute will have only 2 possible values, true or false. And here our target class is also a Boolean. It will have only 2 possible values, true or false. Here I'm going to represent them as yes or no. What is S is? If the Boolean value evaluates to true, it will be represented as S. That is, the target class is S. If the Boolean value evaluates to false, then the target class is represented as no. Now let us see the decision tree for this particular example. I have now 2 attributes in this. First thing is you have to identify the attributes. Here I have 2 attributes. One is A, another is B. You can start with any of the attribute as a root node. But for selecting that, we have one more constraint that we will see in the afternoon class. Now assume that I am going to start with the first attribute, whichever is coming in the left-hand side, as a root node. Now I'm selecting the attribute A as a root node. Now this root node is going to represent a decision. Okay, so here what is the decision is? You are taking the value of A. The value of A can have 2 values in this. One is either true or otherwise false. Therefore, from the node A, you draw 2 branches. One is for true, another is for false. Now, what is the meaning of this expression? I have to find out for what values of A and B, the output will be S. Okay, so now if you see here, between A and B, we have AND condition. That means if I want to say about the value of S, I need to check the value of both this A as well as AND B. According to this is AND condition. In case of AND condition, you will have 2 arguments to that. Both arguments should be true. One of the input here is A. A should be true. Another input is not B. Not B should be true. That means B should be false. So when A is true and B is false, you will get the answer for this particular expression as true. That only we are going to write in terms of the decision tree. So now, first I'm starting with the root node A. The root node A can have any of the 2 attributes, true or false. If A is true, can I tell immediately about the answer? If A is true, can I tell that answer is true? Is it possible? It is not possible because here we have AND condition. In case of AND, when both the inputs are 1, then only you will have the output as 1. So immediately after seeing the value of A, you cannot tell anything about the answer of this particular expression. You have to see the value of B also. So in that case, if you are not able to come to any conclusion about the result, you check the second input also. So the second attribute is B. So you now check the value of B. Again, the value of B can be either true or false. If the value of B is true, what is the meaning? When you will come to this particular branch, you will come here only if the value of A is true. Okay. So when you come to this particular node, what is the meaning is A is true, B is also true. When both are true, here output will be no, because this particular example will evaluate to true only when A is true and B is false. So here you write no. Now try to understand here, this is represented as a different node. This is the leaf node. So the leaf node is going to tell you what is the outcome of your expression. Here the outcome is no. And similarly, you go to this particular branch. When you will come to this branches, A is true and B is false. When A is true and B is false, our answer is yes. So here we are writing the outcome as yes. This is again a leaf node. Now consider this value. Here, when I will come to this branches, A is false. When A is false, can I say anything immediately about the answer? Yes. When A is false, since it is an AND condition, no need to check the value of B. Whatever may be the value of B, definitely you can say the answer as no. So I'm not at all checking the value of B. Immediately I'm writing the answer as no. Okay, so this is called a decision tree for the given example. Now, if I ask you to write the classification rule, what you have to do is see from the root, see in how many branches you have S condition, write all those things. That is your answer. Now, according to this decision tree, the classification rule is A is true and B is false. That is the only classification rule we have.